In this video, we provide a couple of examples of functions of a complex variable that are nowhere differentiable. The first function, which we'll call the real part function, gives the real part of z, where z is a complex number. Sometimes the real part function is written with a fancy script or font in this way, or simply r of z with a fancy font for r. The second function, which we'll call the imaginary part function, gives this time the imaginary part of z when the function is applied to z. The imaginary part function is also sometimes written with a fancy script or font this way, or simply I of z with a fancy font for I. We will show that these two functions are nowhere differentiable. Let z sub 0 be equal to x sub 0 plus I times y sub 0, where x sub 0 and y sub 0 are real numbers, so that the real part of z sub 0 is x sub 0 and the imaginary part of z sub 0 is y sub 0. And so we will show that Re prime of z sub 0 and Im prime of z sub 0 do not exist for any complex number z sub 0. As far as the Cauchy-Riemann equations are concerned, because for this exercise we are going to use mainly the definition of the derivative and some of the derivative's more basic properties, we will not use the Cauchy-Riemann equations, although there are ideas within the video that we will present that can be used to prove the Cauchy-Riemann equations. Let's start with the real part function. With a function that is essentially a function of two variables, we choose two different paths that will give us either two different values or at least one non-existent value for the derivative. For the first path, let's approach z sub 0 along the vertical line through z sub 0. On this line, the real part function is constant at x sub 0. So the real part function has zero rate of change along this line, and therefore its derivative should be 0 along this path. For the second path, let's approach z sub 0 this time along the horizontal line through z sub 0 so that the imaginary part of all the z's along this path is equal to y sub 0. Then delta z will be equal to delta x, where delta x is real. So z equals x sub 0 plus delta x plus I times y sub 0. Therefore, the difference quotient is equal to the real part of z, or the real part of x sub 0 plus delta x plus I times y sub 0, minus the real part of z sub 0, or the real part of x sub 0 plus I times y sub 0, all over delta z, and delta z equals delta x. The real part of x sub 0 plus delta x plus I times y sub 0 is x sub 0 plus delta x. The real part of x sub 0 plus I times y sub 0 is x sub 0. X sub 0 cancels out, so that the difference quotient equals delta x over delta x, which equals 1, so that the limit of the difference quotient as delta z tends to 0 along this path is 1. Therefore, the derivative of the real part function along this path is 1 this time. This is different from the derivative value of 0 that we found for the first path. Two different values for Re prime of z sub 0 along two different paths means that the derivative of the real part function does not exist for any complex number. Let's now examine the derivative of the imaginary part function. Just as with the real part function, we choose two different approaches to z sub 0. In fact, we will use the same two paths. Path 1 again is the vertical line through z sub 0 where the real part of z equals x sub 0. On this vertical line, z should equal x sub 0 plus I times the quantity y sub 0 plus delta y, where delta y is real. It might be tempting to say that delta z equals delta y, but delta z isn't delta y exactly, because subtracting z sub 0 or x sub 0 plus I times y sub 0 from z, x sub 0 and I times y sub 0 cancel out, but not I times delta y, so that delta z is actually I times delta y. The difference quotient equals the imaginary part of z or the imaginary part of x sub 0 plus I times the quantity y sub 0 plus delta y minus the imaginary part of z sub 0 or the imaginary part of x sub 0 plus I times y sub 0 all over delta z. Delta z is I times delta y. The imaginary part of x sub 0 plus I times the quantity y sub 0 plus delta y is y sub 0 plus delta y. The imaginary part of x sub 0 plus I times y sub 0 is y sub 0. Y sub 0 cancels out. So the difference quotient equals delta y over I times delta y, and so is equal to 1 over I, or minus I, whose limit, of course, is minus I. Therefore, the derivative of the imaginary part function at z sub 0 along this path is minus I. Path number 2 is the horizontal line through z sub 0 with the imaginary part of z equal to y sub 0. So this time, the imaginary part function is constant at y sub 0 along this path, and therefore its derivative or rate of change along this path is 0. Once again, two different paths, two different derivative values, so that the derivative of the imaginary part function does not exist for any complex number. Therefore, the real part function and the imaginary part function are nowhere differentiable.